Please don't forget to subscribe to my channel and click on that like button if you like my video. Also click on that notification bell. Thank you.
Now let's go over our training syllabus and see what exactly are we going to cover in these 3 days. The first day is we're going to cover the installation, configuration, file system, and basic commands. So we will start off with a little bit of understanding what Linux is. If you really know what Linux is, just skip through it. Then we will install VirtualBox in our environment. And the reason we need to install VirtualBox because we have to set up a lab. Once the VirtualBox is installed, then we will install Linux, which is CentOS operating system, on our virtual machine. Then we'll connect our Putty. We download the Putty. We connect to a Linux machine through a Putty, and then continued on Linux day 1, we will learn how to change password, start the introduction to file system, the file system structure, file system navigation commands, which are the 3 most basic commands of file system navigation. We'll cover the directory listing overview, which means every time you run ls command in your Linux, you will get different fields, and we will cover each field one at a time. Creating files and directories, what are those different commands? The file system paths, there are different type of paths: absolute path, relative path. Finding files and directories, the wildcards, and of course every day we will have few quizzes, the homework for you to do, and a few handouts for you to read. Day 2, we will do the Linux system administration. This is what most of the administrators, engineers in Linux capacity follow every day. And here we will start with the file system permissions. Some of the commands are change mod, change ownership, change group. We'll know how to get help while we are in Linux system. How we could add text to a file without doing a VI editor. We'll learn how to combine commands through pipe. Some of the file maintenance commands that you really need to know. Everyday commands like copy, remove, move, and making directories. The display commands will display the contents of the file, and there are many different commands that we will learn in that. The filters and text processing, like cut, sort, grep, and many other commands. Comparing file, compressing, uncompressing. We'll continue our day 2 with Linux file editor, where we will learn how to edit a file using VI. Then we'll learn how to manage user accounts by creating user accounts, creating groups, and removing and managing them, switching users, monitoring users, talking to users, and some system utility commands that will help you find out some of the information while you logged in. Day 3, we'll get into advanced Linux system administration. Now this includes the process and scheduling like cron tabs and running system processes. Once you run them, how do we monitor them? How do we monitor those commands? How do we monitor the processes? There are so many different commands that we'll cover. Maintenance command, changing host name, file system information, terminal control keys, kernel. We'll talk about what is a shell. We'll learn basic stuff about shell scripting, and I added one bonus if then shell script if you wanted to get into some advanced level shell scripting. Then continued on day 3, we'll learn alias, some history command. We'll enable internet on our Linux machine so we could access the network files and commands. So then we have network interfaces. How do we check the network interface, its status, and its configuration? How do we update our system? And difference between update and upgrades. The system run levels, how to transfer files from one system to another. Message of the day, and disk partition. At the end, always every day we will have quizzes, homework, and handouts. Please don't be scared that there are so many things you will have to cover, but I'm telling you, if you are dedicated enough and spend a few hours every day, you will cover it with me and you will be able to perform many different tasks in Linux.
Welcome to day 1. Today we will learn the installation of Linux and its configuration. We will also cover the file system, what are the different type of file systems are out there, what exactly a file system is, also followed by some Linux basic commands. Linux file system. Now what is a file system? A file system is basically, think of as a closet, as a shelf. When you come in, you change, you put your t-shirts in one shelf, you put your socks in another. So there is a systematic way in your closet where you put all your stuff. The file system in an operating system works exactly the same. The operating system has file system where command files go to a different folder, peripheral devices or files go to a different folder, all the programs and applications that you install go to a different folder. So it will be easier, much easier for operating system to access those files. Now, operating system stores data on a disk drives using a structure called file system, consisting of files, directories, and information needed to access and locate them. There are many different type of file system. In general, improvements have been made to file system with new releases of operating system, and each new file system has been given a different name. In Linux, we have file system called extension 3, extension 4, XFS. And in Windows, it's the file system called NTFS or FAT. Linux file system stores information in hierarchy of directories and files, meaning there is a first folder, one folder, which is a slash, a root file system, and every other file actually created within the first file or directory. The file system structure in Linux actually looks like this. As I mentioned, the first file system or first folder always start with slash, which is also referred to as root. Now please keep in mind slash root is not as just slash. Slash is the first directory structure where you have to start your navigating your file system. And then underneath it has different folders. As you could see, it has bin, boot, dev, etc. So this is the way Linux structure its file system. Or if you compare this Linux file system with Windows, you will see the Windows has also something like that, similar structure, but they have given a different name. So let's look at the Windows file system. If you go to Start and you go to Computer, you're going to see your C drive. In this case, our C drive, when we refer to our file system structure diagram in the background, you'll see right here, this one has slash. So in Windows, it starts with C. So C or slash is the same, but C in Windows and slash in Linux. So when you double click on Windows C drive, you're going to see all those different folders. Now, why do we have all those different folders? Why not just one folder? And it would be so hard for the operating system to find the right file or directories that you're looking for. So for example, like apps and Dell, then you have Intel folder, all the Intel chip related files are in that directory. The logs, program files are the folder when you install a third party applications. That's where they are downloaded or the files get. Then we have another one, program files x86. That's where the 32-bit related directories are created, and users, that are the user directories. If you click on it, you'll see my directory right here as well. And then of course the Windows, anything that related to Windows. So that's why it is predefined by Windows that every time we create a file or every time we install a program, automatically it gets installed into these files and directories. So just like that, when we come here, you'll see here that this is the file system the same way in Linux this file system is created, but of course the naming convention is different. Now let's take a look at our Linux file system. So I'm going to open up Oracle VirtualBox. So let's go to the file system. So as I said, in the Linux file system, it starts with a root. So when you do cd slash, which is root slash, hit enter, and then you do ls minus l. Here you have a list of all the directories and files that are starting with slash. you could go into each of these directories and you could see how the file system is structured. So I hope you guys got the gist of how the file system looks like and why do we have file system in our operating system.
What is Linux? So, of course, we are going to learn Linux, but we do want to know what exactly Linux is. Linux is an operating system. It's just like any other operating system. For example, Microsoft has Windows, Apple has Mac, Sun, which is now owned by Oracle, they have Solaris running on Spark hardware. So, Linux is an operating system which sits in the middle of your hardware and the users. And the users are the one who run the applications. So it's like a middleman or a bridge that takes the commands from users and translate them to hardware. So look at this picture. So you see a computer, right? So without an operating system, this computer is considered like a dumb terminal. It doesn't do anything. So how does it work? So um, we have this terminal, which is of course a piece of brick. You open the tray of that computer, you insert your CD or DVD in. That CD or DVD has the operating system image sitting on it, whether it's a Windows or whether it's Linux or whichever operating system that you are installing. So you boot your computer from that operating system. So once you're booting it up, it goes through the installation process. That installation process is going to ask you a bunch of questions like how do you want the operating system to be configured, how do you want your disk partition, how many users you want to have installed, and so on. So once the installation is done, then at the end of the installation, it's going to ask you to reboot. You reboot the computer and it comes up to the welcome screen and it'll say welcome to Linux or welcome to Windows or whichever the operating system that you're installing. So then you could attach external devices to it. For example, you could attach keyboard to it, you could attach mouse to it. So you use these mouse and keyboards, you type certain commands, you use applications and type them, and then you send it to your operating system. Then your operating system takes those commands and forward it to other hardware or other system peripherals. So some of them are, for example, we have printer. So if you are running an application, for example, you're running Microsoft Word, you type it in with your keyboard and then you want to print that document, right? So the operating system will take that document and send it to your printer, and your printer will spit out the document that you want to print. Or if you are running other programs, for example, you are online, you're checking your email, or you are running some online program or even games. So you are using your keyboard or your mouse, you communicating with your operating system, and the operating system communicates with your hardware, and that's how it communicates to other devices on the network.
Hey, beautiful people. In this video, I want to spend some time and go over the operating system. Now, of course, our focus in this entire course is Linux, and Linux is an operating system. So before we start getting into Linux, let's understand what exactly an operating system is. So, as per Wikipedia, an operating system is system software that manages computer hardware and software resources and provides common services for computer programs. Or, in simple words, an operating system, in short OS, is software that acts as a middleman or a bridge between computer hardware and the computer users. What are the hardware? Like CPU, memory, disks, and who is the computer user? You are the computer users. It provides a user interface and controls the computer hardware so the software can function. Now, which software are we talking about here? Software or applications that actually run on your computer. Now, let me ask you a question. Why do you use computer? because you want to use certain applications, right? You want to use, for example, Microsoft Word, Excel, you want to get online, you want to use Firefox or Chrome browser, you want to use calendar, calculator. All those applications are the main reason you have your computer at home, right? So when you start up your computer, the very first thing that starts up is your operating system, which allows you to start or operate other applications running or installed in your computer. Okay, now let's go over the different type of operating systems. The first one is desktop operating system. These operating systems are like Microsoft Windows, Mac OS, and Linux such as Ubuntu. They run on your regular computer or your laptop that you are using probably every day at home or in the office. Then you have server operating systems, for example, Windows Server, Linux distributions like CentOS, Red Hat, SUSE, and so on. These type of operating systems are actually run on corporate or enterprise level environment. Then mobile operating system, for example, Android, iOS, Windows Mobile. If you have Samsung phone, you have Android operating system that controlling that phone. If you have Apple phone, you have iOS operating system in it. If you have Microsoft phone, then you have Windows Mobile operating system running on it. Then embedded operating systems used in devices like routers, smart TVs, automobiles, home appliances. Then you have real-time operating systems, in short, RTOS, used in critical systems like medical equipment, car ECUs, aerospace, defense, network firewalls, home security system, and so on. So I hope you have a better understanding now what exactly an operating system is. Now we will jump into Linux, which is an operating system. What is Oracle VirtualBox? And of course, why do we need to know about VirtualBox? Well, for this course, you do need to install CentOS Linux operating system on your computer, and there are two ways you could install it. One, you could remove the existing operating system that you have on your computer, or you could install VirtualBox on top of your existing Windows operating system or Mac, and then you could install CentOS, so you this way you won't lose anything. So basically, VirtualBox is a free and open source hypervisor for x86 computers currently being developed by Oracle Corporation. It installs on your existing Intel or AMD based computers, whether they are running Windows, Mac, Linux, or Solaris. It extends the capabilities of your existing computer so that it can run multiple operating systems on one hardware at the same time. Let's see how it works. So you have when the hardware layer, and then on top of it you install the operating system. Of course, it could be any one you have that is Windows or Mac, and then you install Oracle VirtualBox. It's just a program, a software that you install on your machine like any other software that you would install. Once you have installed Oracle VirtualBox, then you could install Linux on it as a separate small version of operating system. You could have Windows on it, or you could have Mac on it. So this VirtualBox allows you to have multiple operating system on a same hardware. Wildcards. What are wildcards? Just as its name says, they are wild cards, meaning if you play cards, and in poker or blackjack, they do pick a card like a 10 or 9, whatever the card, and you could match it to any of the card to make your flash trail or whatever that you like. So that is kind of a wild card. So just like that, in Linux we use wild cards to get the output that we are looking for. A wild card is a character. Now, this is a definition right from the Linux dictionary that can be used as a substitute from any of a class of characters in a search.
So there are many wildcards, but the most basic ones I have listed here. There are three. The first one is the one I use most of the time is asterisk, which is also referred to as a star. A star represents 0 or more characters, anything that matches with that star placeholder. We'll look into that in a moment when we actually use the star wildcard in our Linux machine. Then we have question mark, represents a single character. So if you have a file name text and you are looking for any files that has the word text, and you could use TE instead of X, you could just put question mark in there and then T. That means whichever files that had TE, doesn't matter what's inside of it, the X and the last letter is T, then it will work. The third one we have brackets, which represents a range of characters. So it's better we'll look at it in the Linux machine to understand them more deeply. I'm going to bring up my machine real quick. Where did it go? Right here. I'm logged in always as myself, and I'm in my home directory, of course. Now, right now, these are the files and directories exist in my home directory. I want to create 9 files that has a name, let's say ABCD1 and XYZ. And then same thing, instead of 1, it just increments the number 2, 3, 4, 5, 6. I could do this, touch ABCD1-XYZ one time, then hit up arrow key again, change 1 to 2, change 2 to 3, and keep going. But don't you think it's cumbersome and tedious? It is, right? So we use wildcard to perform that task because we're going to create 9 files. So it's just a practice that we are doing for 9 files. Trust me, in corporate environment, you're probably going to have to create like thousands of files. What you going to do? You're going to just hit up arrow key or type it 1,000 times? No, that's not productive. So then what do? We use wildcards. So first of all, I'm going to do is I'm going to remove these files one by one. Again, I could remove it wildcard as well, but let's create it first, then I'll show you how I could remove it. So I have 2 left. Now I could use a wildcard to remove both in one shot. Remove ABC wildcard. So what is telling it? Remove everything that has a file name that starts with ABC, and whatever that comes afterward, you don't care, just remove it. I hit enter, and that's my LTR, and you'll see all those 2 files are gone. Now I'm going to create 9 files, and to create 9 files, I'll use the command touch. As you know, the touch is the command to use. And then there is a wildcard, another wildcard that's called curly braces. So I was creating file ABCD curly braces 1.9 because I'm going to create 9 files. So this curly braces 1.9 is telling you create 9 files that has the digit 1 through 9 and dash XYZ. When I run this command, what do you think that I will have listed in my home directory? I will have 9 files. Right here at the bottom, you'll see I have 9 files. Awesome, right? This is what you wanted to do. It is much more faster to do in the wildcard as opposed to typing one by one. So let's use the asterisk. What I just want to list every file name that starts with ABC. You do ABC asterisk, and you will have all the files that starts with ABC. I want to remove every file that starts with ABC. You could remove one by one ABCD1 and so on and so forth. Again, very cumbersome. Don't do it. You're a system administrator. You are smart folks. You don't want to use the commands one by one. What you would use? You'll use a wildcard. So you'll do ABCD or AB and do asterisk. The reason I picked the 4 letters is because if I just pick A and hit asterisk, it will also remove any other files in my home directory that starts with A, and which I don't want it to do it. Right now I don't have any files. So let's say if I create a file touch A. So now I have all the files and A. So I just want to confirm I don't have A, so I don't delete any file accidentally. So yes, I don't have any file that begins with A other than these. So if I just do remove A asterisk, it will remove all the files that starts with A. Let's check it. See, all those files are gone. Isn't that cool? Yes, it is. I love this asterisk because I use it all the time. I'm gonna recreate those files again by hitting up arrow key. That will return my last ran command. Just confirm they are there. Now what if I want to remove everything that ends with XYZ? Same way, remove, but this time we'll put asterisk in front of XYZ. Hit enter, boom, all gone. Awesome. I'm gonna recreate it just for the exercise of this lesson. It created 9 files. Now we'll move on to the next wildcard, which is the question mark. The next question mark is telling it ls minus l question mark b c d asterisk. Okay, what am I asking here? I'm asking is give me all the files that has whatever the character is the first, as long as the other characters has B, C, D, and whatever comes afterwards. These are the matching files because whatever the first character is, whether it's A or not, I don't care. I just want to make sure I will get the listing of the files that has B, C, D in it and after the A. So that's how you use the question mark. And the last one we have brackets. Bracket is going to tell me that give me anything that has C or D letter in a file. It's just that simple. Either C, either D, either F, or this and that. So you put all that stuff that you're looking for inside of the bracket and you will have all those files you see here. And it went so fast, so I'm going to put it in more. The output, I want to see one page at a time. And you'll see it gave me, and it has A, it has B. Every file that I'm getting has either has A or B, either has A or B. So that's how it works. That's how the wildcard works. Again, now I want to get rid of all the files that has X and Y in it. Awesome. I have my wildcard. I'm not going to go and delete one by one. So this command is telling the shell that go ahead and please delete all the files that has X and Y in it. And X and Y has to be together, of course. So we do have these matching files, X, Y, and it will go ahead and delete it. And all of them are gone. So wildcard not necessarily is used just with ls or remove. You could use it with any of the commands we have. You could use it with all the commands we have learned so far. Try it with different commands. If it doesn't work, that's okay. Go online, Google it, and try wildcard examples. Try them, just get familiar with them. This will help you a lot in your job, I promise you.
In this lesson, we wanted to cover quickly how we can download and install Putty, which is a terminal client to connect to the Linux machine. So this is how the Putty looks. So let's look at how we could download it. First, we'll go into our web browser, open up a Google, and we'll just simply type download Putty. The first link you get, putty.org, click on it. And the first link, download Putty right here. Click. And then you're going to get 2.msi files. These files are used on the Windows machine. So if you have Windows 32-bit, you could download this one, or if you have 64-bit, you could download this one. I have the 64, so I'm going to download this one. It will save the file to your desktop or wherever you have the location on your browser set to. Alright, download is completed. It should be on my desktop. It's right here. I'm going to double click, run, next, leave the default, next. Here it will have add shortcut to Putty on the desktop. I want the shortcut of the Putty and will be installed on the local hard drive. Yes, click install. Okay, the last screen is going to ask you to view the README file. You don't have to. If you want, you can leave it checked on. And then click finish. Once in finish, you go to your desktop, you're going to see this Putty shortcut created on your desktop. So you could just simply double click, and this is the Putty client that you have. So we're going to put in the IP address, and the port is already set to 22, and then we'll connect to a Linux machine. But first we need to find out what is the IP of the Linux machine. So let's look at that in our next lesson. Hello and welcome to day 2. Today we will learn all about the Linux system administration and all the tasks that are related to manage a Linux system. Hello everyone and welcome to our new lesson, User Account Management. In this lesson we will learn how can we manage user account in Linux file system. There are a few commands that we use to manage user account. The first one is user add, is to create a new user. Group add, to create a new group. User delete, delete a user that is already created. Group delete, to delete a group. And user mod, which is to modify a user. Now whenever we create a new user, those user management are created. Their record is maintained in 3 different files. The first one is etc password, second one is etc group, and the third one is etc shadow. Now remember, etc password is not a complete word password, it's just passwd. The example to run a user command which includes all the parameters that you have to define is as follows. It goes with user add -g with option to add a group, -s to option to give a shell environment, -c to define the user description, -m -d to define the user home directory and the user itself, and the user home directory itself and the name of the user. Now let's look at our Linux machine and we will practice these commands and learn these commands more into detail. I will log into my Linux virtual console. Let's move this a little to the side so we could see what are the commands that we will be using. Okay, always first thing first, you need to find out who you are. You are yourself. Where are you? You are in your home directory. Perfect. And what's inside of your home directory? Just to confirm you are in the right place. Yes, you are. When you have confirmed this, just do the clear screen. Now we're gonna create a user called let's say Spider-Man. Before I create a user, I wanted to add that user to a group that is, let's call it superheroes.
So in order to use these commands, you have to be root. So become root su space minus dash. Okay, the first command that we will run is user add space Spider-Man. You hit enter. It gives you the prompt back, which means it did create your user Spider-Man. How do we verify if the user is created? There's a command to check if user is created. It's called ID Spider-Man, and it'll tell you that there is an ID assigned to the user Spider-Man, and the group is created called Spider-Man, and the group's IDs, so on. You could also verify by going to the home directory. So home. If you notice that it created right here the Spider-Man. The next command that we want to learn is group add. I want to create a group, a new group, and the command to add a new group is group add, and I wanted to name it superheroes. It adds the group. We could verify it by looking at the group file, which we'll cover in a little bit, but if you wanted to see it, you could just do cat at c groups. And at the bottom you'll see it created this group name superheroes. Now I want to delete the user I created Spider-Man. The command to delete is user delete. Now if you want to delete the home directory of Spider-Man, which is right here, you will run the command user delete with -r as well, so it would delete the directory as well. So it deleted the user, and let's check if it deleted the home directory. Yes, it did delete the home directory as well. So it deleted that. I created a user before just called Spider, just for testing purposes, as you can see it here. The next command we have to do is, of course, the group delete. So let's try to delete the group. Let's not delete our group superheroes. We'll create a new group and we'll delete it just for training purposes. So let's create group add no new group. Let's call this no new group. The group add is created. We can verify it by going to the group file and see at the bottom it says no new group. That's the new group ID. We could delete the no new group, delete no new group, and it's deleted. We could verify again at the bottom. See, it's gone. The next command that we have to learn is user mod. This command is used to modify the users. You could run man on user mod to see what it does. It modifies a user account. If you notice, A appends it as a user to supplementary group, C the new value user password, D change the home directory. So these are the things if you wanted to do after you create a user. So we will use this command to add our user Spider-Man. Let's see if we have Spider-Man first. Oh, we deleted Spider-Man, so let's create Spider-Man again. User add Spider-Man. As soon as you add the user add Spider-Man, it automatically creates its group as well. If you don't specify, it creates a group with the same name as user IDs. Now I wanted to add Spider-Man to a different group as well, which is the superhero. So how do we do that? User mod -g, what's the name of the group? Superheroes, and the name of the user that I wanted to add is Spider-Man. hit enter, and it is added. How do we verify it? You do cat etc, but instead of doing the cat and viewing the whole file, how about we use grep command and just type spider-man from etc group file. And there you go, you will see this is the super user group, and Spider-Man is also part of that group. This is the Spider-Man's own group name and own group ID. So Spider-Man has its own group, and it also belongs to a group called superheroes as well. Now if you notice one here, when you do ls-ltr, the group of Spider-Man right here is still Spider-Man. Why didn't change to superheroes? Because its actual group is Spider-Man will always remain Spider-Man. It is part of the other group as well, which is superheroes. If you want this to change, then you have to run the command change group, and then you specify superheroes, and then you specify Spider-Man. And remember, we have to use -r option to cascade this permission of the group to every folder of the Spider-Man. So let's run this command and now see if it changes from Spider-Man to superheroes. Yes, see, now the user is Spider-Man, the group is superhero. So that's how you use these 5 different commands: user add, user group add, user delete, group delete, and user modification. And the files that it creates its information is the first one is etc password. Let's look at the etc password, cat etc password, and you'll see at the bottom, as you add a new user to the Linux system, it adds the information of the user at the bottom, appends at the bottom. Spider-Man and the spider, the one I created earlier, both are in there. The first column tells you the name, the second one tells you the password, which is encrypted. It's just give you the X. Second one tells you the user ID, and then the group ID. And right here in between these 2 columns, we didn't specify the description, so it's empty. And then here it's the home directory of the Spider-Man, and then at the end it's the shell the Spider-Man is using. So that's the description of the etc password. Let's look at the description of etc group. In etc group, you have the first is group name, and then the group password, which is the same password that is used for anyone within that group, and then the group ID. The last column that you see here with a few of them, that means that these other users are also part of this group. Then the last file we'll look at is this etc shadow. etc shadow file is strictly for passwords of users that we create. This does not mean the password right here is the actual password. It's just encrypted so we don't see it. However, it does have some other parameters, like the password does not expire at these many days. There are password length restrictions and so on. You could view that in man command of creating users. You'll get more information about etc shadow file. Again, if you are specific about one user, let's say you just wanted to know the information about Spider-Man in etc password, you do grep Spider-Man etc password, and you will only get the information about your matching criteria, which is Spider-Man line. Now we will look at the last example, which is the example that is mostly used in the corporate environment, that they will run one big command that will take care of all the parameters. So let's create a new user add -g to specify the group, which is, we already have a group superheroes. And let's look at let's minimize this so we can move up and view our command. Okay, Okay, superheroes. Minus S means the shell that you want to give. There are different shells. There are bin, bash, corn shell. We'll cover that later. Minus C is the description. You have to specify the description. Superheroes, you want to create Iron Man, so Iron Man character. Just a description, nothing more than that. Then minus M, minus D, and specify the home directory, which is home Iron Man space Iron Man. This will create a user Iron Man with all the parameters we have specified. And how do we verify? You just do ID Iron Man, and you'll see that Iron Man is there and is part of the group superheroes. And you could also view it in etc password file, and you see at the bottom it's there. Now, one thing that we do have to cover every time you have to create a user, make sure you create its password. So the command to create a password is just simple password Iron Man, enter, specify the password. And the password that I've specified, it says password fails the dictionary check. It is based on a dictionary. You could ignore that as long as you're running as root, but if you're not root, then it's gonna force you to change the password that is not based on dictionary. But again, you are root, you could do anything. So this concludes our lesson for user account management. The basic commands are these 5 commands, and the files that are used to manage this is etc password, group, and shadow. Since we know how to manage user account, now it's time to learn about how do we switch users and how do we allow sudo access to user. What is a sudo access? It's basically a command which allows an ordinary user to run root level commands. The commands that you could run to switch from one user to another is simply su space dash space the username, and then it will ask you for the username, password. You enter that and you become that user. The next command is the sudo command. This is how you run the command if you do not have root privileges, or you cannot become root, but you still need to run certain commands. Then you will run sudo followed by the command. And then the last command is vi sudo. Vi sudo edits the etc sudo file, which is a configuration file that allows user to add or remove the rights to run certain commands, and the file is etc sudo. If you remember at the beginning, we talked about file structure and we talked about the etc. Again, etc is the folder or directory in Linux where all the configuration files are stored. Now let's look at these commands one by one by logging into our Linux machine, and this time we will log into our Linux machine through the Putty. First, we need to find out what is the IP address of our Linux machine. If we don't know, we just log in, clear this out, and the command to check the IP address of your Linux machine is ifconfig. You hit enter, and the IP address is right here. This is the primary interface that is used to communicate to other computers. This is the local interface, you could ignore that, and this is another interface, you could ignore that. It's for private communication. So focus on this one. Open up your Putty terminal and type in the IP address 192.168.56.101. Enter, put in the username and password. Once we are logged in, we could simply minimize this console access. Now we will be using the Putty. Make this a little bigger.
Okay, so we logged in as ourself. Now, what if we wanted to become another user? So you do su dash Spider-Man. It will ask you for the password, and then you become Spider-Man. Let's exit out, go back to our account. What if you want to become root? Simply do su dash, which we have covered many times. You'll enter the password and you become root. When you are root and from this level you wanted to switch to a different user, let's say Spider-Man, then it will not ask you for the password, because super user or root account is very powerful, that does not need any other password to be authenticated. We are Spider-Man. Let's go back. We are now root. Let's go one step back, exit out, and we are ourselves. Let's clear this out. Next command we will learn is sudo. Sudo is the command that is used to run different commands that is only owned or only has permissions by root to run them. For example, one of the command is dmi decode. You will run that. That will give you permission denied, because we cannot run that command. Another command would be, for example, fdisk to check the disk size. It will give you the permission denied as well, because we do not have the right. Again, who am I? We are ourselves. So how do we get the permission without becoming root? Well, only root can allow that. I could become root here and run the command. So su to root and hit enter. Now I'm root, and the command that I will run to add a group to etc sudo file is visc sudo. For here you need to look for the group named veal. Veal is the group that is automatically by default added to this file. We go down, we're coming down. Remember to come down when you are in VI mode. You come down, you use your up key, right key, bottom key, and there you go. So this is the veal, and it tells you this group allows people in group veal to run all commands. So all we need to do is to add IMf&x into the veal group, and it will allow all users, whoever in veal group, to run all commands. So it's already added there. We don't have to modify the etc sudo. If you wanted to add a new group, or if you wanted to add a new user, then you would change that to allow run all the commands. Let's say if you wanted to add IMf&x to run all user command, then you would put it right here. You put IMf&x all dash all tab, and then you will run sudo command, and you could become root rights to run any command. But we don't want to go at the user level. We will stay at the group level. So what I'll do, I'll delete this line. To delete a line is dd, and then I'll save the file. Now we know that we need to add user to veal group. So to add a user is user mod -g, and the command is the which group is veal and which user is IMf&x. Enter. How do you verify? You grab veal from etc group, because group is the file that manages that user, manages all the groups, and you'll see right here, now I am part of the group veal. So if I become myself, so etc IMf&x, who am I? I'm myself. So if I become myself, now if I run sudo dmi decode, it will ask me for the first time password. Oh, okay, so the command that I typed was wrong. Sudo dmi, not demi.
decode. Sorry about that. There you go. See, now the command is running. What if you run this command just without sudo? It's not gonna run. You have to run the command sudo followed by the DMI decode, and that's how it will run. You can also run the second command sudo fdisk, which will tell you the size of your disk, and here it will tell you your size of the disk is 10.7 gig and all the partition information, all that. You can only view that information only if you are root. So this is how we do switch user from one user to another, and we add a user to become a powerful user or run powerful commands that is only owned by root.
Pipes. A pipe is used by the shell to connect the output of one command directly to the input of another command. The symbol for a pipe is the vertical bar. The command syntax is command or the option or the argument, and then you pipe it to another command with its option or argument if there is any. Basically, if you want to connect two commands together, or if you want to take the output of the first command and pipe it to a different output, then you could use a pipe. In a Mac keyboard, a pipe is somewhere the key all the way to the right that looks like that. And in a regular keyboard, you'll see the pipe option is right below the backspace, and you could do, I think, with the shift and pipe. So the way it works is you have a command, it goes into a pipe, and it comes out the output. So let's say if you have ls-l, that's a command you run. You pipe that, the exact same pipe character that you use, and you put another command to it to refine the output of your last command. So let's look at the example in our Linux machine. If we are in /etc directory, by the way, where we are in our home directory. So if we go into cd/etc, now this directory has a bunch of files and directories which you cannot view all in one page. It will display all at once, but everything will scroll up so fast that you wouldn't even able to view one by one. So when you do ls-ltr, you hit enter, you see it went up so fast. What you could do, you could scroll up. So of course when you do scroll down slow by slow, you're gonna see all those files, commands, and directories that are inside of etc. Now you want to view all of them one page at a time. So how do you do that? The way you do it, you put it in a pipe. So you do ls-ltr, you pipe it, and then there is a new command that I want you to learn, which is called more. More is the command which gives you the output of a file one page at a time. So when you do ls-ltr, pipe it and more it, hit enter, go. Now you will see one page at a time of all the contents of etc directory, and at the bottom it does tell you that it's more. You hit spacebar to go down to the second page, spacebar again, wherever you are. You could quit out of it by hitting Q, and you'll get your prompt back. Again, let's do up arrow key, hit enter, spacebar to go all the way down. You could keep hitting the spacebar and get your prompt back. So that's how you put in a pipe. You could also do a pipe to have the output of a command and change its output to a different way. Let's say if you wanted to do ls. By the way, there's another command which is a simpler command if you wanted to learn is ll, which also gives you the result as if you are doing ls-l. So you do ll and you learn the command more, which will give you one page at a time. What if you wanted to get the last line of your output? Then you run ls-l, pipe it, and to get the last line, you would have to do tail minus 1. It gives you the last line of your output. Now tail is another command which is also a cool command which will give you the last line or lines of an output, which we'll cover later on. So this is what the pipe is. I want you to try with different commands, learn about pipe. I'm not sure if there is a man page for pipe because it's a character, but let's see. Yeah, there is none. But if you wanted to know more about pipe, I have some documentation. You could get it, or you could, of course, look it up online to find out more about pipes. The pipe is very important for our lessons that we will be covering later on because this is how we're going to combine our commands. Let's monitor users. We have created them. Now we have to manage them because that's one of the basic job for any system administrators or engineer or a systems guy to monitor the users, what they are doing in our system. Some of the commands to monitor those users are who tells you who isn't logged into the system, last, W, finger, and ID. These are the few commands. There are many other commands as well, but these are the few basic commands that are mostly used in Linux environment where you could monitor users. Let's look at our Linux machine by going into our Linux console and run these commands to practice them. Okay, we are logged in. Let's clear our screen and see who we are. Good, we are self and we are in our directory, and of course now you should know to type hostname, and our hostname is the name of our system. Let's clear this. The first command is who is going to tell you how many people are logged in and their user ID, their terminal ID, and the time they were logged in. So I have logged in my console in my GUI with colon 0, and I have opened up a terminal right here which tells me the PTS is the terminal /0 and the time I opened it up. If I wanted to open up another window, so you do right click and open terminal. See, it open up another terminal. Now when you type who, it should show you three terminals that is owned by IMf&x. What if I log in as Spider-Man? So let's go to our Putty terminal and put in our IP address. I believe it's 192.168.56.101. Sorry, 56.101. You could check that by again running the command ifconfig. There you go. See. So we'll open that. Now this time we'll log in as Spider-Man. Okay, and now let's clear the screen and check. Now you see we have 4. 1, 2, 3, 4. And the fourth one is used by Spider-Man. So this is the main function or main purpose of the command who. The reason we run this command who all the time or most of the time is when there is a very high load in the system and you want to see how many people are logged into the system. Next command we're going to learn is last. Let's close the one in the back. Last command tells you all the details of every users that have been logged in since the day one. So when you type last, hit enter, you see everything comes up in the screen so fast. I wanted to see one page at a time. Then how do I do that? You do last, pipe it, and more it. And this will tell you the last time the user that logged in is Spider-Man, of course, but this is the name
This is the user that I logged in, and this is the time I logged in, and it's telling you it is still logged in. And it tells you every user that's been logged in, and every user who's been logged in and rebooted the system, and whatever happened to the system. So let's say if your system reboots or shuts down or crashes unexpectedly, and you suspect someone was logged in, and you wanted to see what time they logged in, which IP they used to log into, what date and time they logged in, all the information is here. If you wanted to see the first column of your output of last, this is your last, right? Last, and you run that, and you wanted to see only the first column, all the usernames only, then what command you would run? This is a kind of pop quiz. You do last pipe it awk $1, and you get the first one. Now you just wanted to remove the duplicates, then what do? You do sort, that sorts out, and you type unique. There you go. And then you will see only these are the users that have been logged in. IFSolve, reboot, that's also a protocol that is used to log in, Spider-Man, and there's another user, WTMP. Another command that we'll learn is W. W works pretty much the same as who, but it will give you a little more information than who. It gives you the login time, the idle time, and what are the processes is being run by what user. So it gives you a little more detail. The next one is finger. When you run finger, now finger command is the command that is added to your system. So it does not come with your distribution. You have to add it. It's a program. It's a very powerful program. It basically does the trace of your user, where is it coming from, what kind of protocol is using. So you need to install that. So we will leave that out for now. The next one is ID. When you hit ID without the username, it will give you the information about your own self, your username, your group ID, and what part of other groups you are. If you run ID and you do Spider-Man, then it will give you the information about the other users. So these are the few commands to monitor the users. I hope you will remember them, and I hope you will practice them. Again, the way to practice is to run them with different options. And how do you find the options? Is by running man and do who, and you will find different options. And I would highly urge you to please use different options just for practice.
Hey, beautiful people. In this video, we will go over the difference between Linux and kernel. What exactly a kernel is? Where does it reside? Is it the same as Linux? These are many questions that a lot of people have in their mind. So I'm going to clear that confusion today. All right, the terms Linux and kernel refer to different concepts, but remember they are related. Here's how they are different. First, kernel. The kernel is the core component of an operating system. It is responsible for interacting with the hardware of the computer, managing resources like CPU, memory, and devices, and enabling all the software applications to run. It acts as an intermediary or a bridge between the hardware and the software, handling low-level tasks like managing file system, scheduling processes, and controlling peripherals. There are many different type of kernels like monolithic kernel, microkernel, hybrid kernel, each with its architecture and design principle. So let's vision this. You are the user and you are executing a command or typing something on your keyboard. That execution is transferred or given to your operating system. Then operating system tells the kernel to utilize system resources, as I said, CPU memory, to perform or complete your required task. All right, now let's go to Linux. When people refer to Linux, they usually mean a complete operating system that uses the Linux kernel at its core. However, of course, strictly speaking, Linux originally refers to just the kernel developed by Linus Torvalds in 1991. A full Linux operating system, also known as a Linux distribution, includes a Linux kernel, system libraries, software applications, and graphical user interface, among other components. For example, of Linux distributions, there are Ubuntu, RHEL, CentOS, Fedora, Debian, each providing a different set of software and user experiences on top of Linux kernel. Now, let me put it in a very simple terms. The kernel is like the engine of your car. It's the essential components that makes the car move, managing all the underlying mechanism. Whereas Linux, of course, in everyday language is like the entire car, including the engine, which is kernel, body, which is sublibraries and utilities, and interior, like software application and user interfaces. So I hope this actually clarifies the difference between kernel and Linux. But again, in short, kernel is basically a small program that comes inside of an operating system.
Next lesson we have compressing and uncompressing files. There are a few different commands that we use to compress and uncompress files. But first of all, there is a command that is used commonly in Linux, and that command is called tar. What does tar do? Well, tar takes a bunch of files together and put it in one container or one file, you could say. It's just like in Windows, you have a bunch of files and you zip them together. So most likely the tar files does not compress as much as the actual gzip command. The gzip is the command is actually compresses a file, and then there is a command gzip -d or gunzip. These two commands are used to uncompress a file. So let's get to a question, our favorite question. Why do we need these commands anyway? It's a very good question, of course. To answer this question this way is, what happens if your system crashes? Okay, you try to resolve the issue, but you cannot. You tried everything, but you cannot find the issue. You cannot get to the point where you know, aha, that's the problem. So what do? Are you going to sit there and just, try your endless hour to resolve it? No, what you're going to do is you're going to call the support. You're going to call Red Hat or the operating system support. If you're running CentOS, then most likely you are out of luck because most of the CentOS has no support. So I hope you're running Red Hat in your corporate environment. When you are running Red Hat, you will get a support. So you pick up the phone, you call them. Then what happens? They will tell you to send the files or logs to their websites. And sometimes there are so many logs, so many files that they ask you have to put them together into one file or one container. When you put them all of them in one container, that is when you're doing tar. Or in Linux language, you could say tarring. You put everything together. All right, so everything is together now. Now, if the file size is huge, it will take so long to transfer. So what do? We actually compress it. Once we compress it, the file size becomes a lot less than its actual size. So we'll try all these commands in our Linux environment one by one, and this way you will understand how these commands work. All right, I am in my home directory, and someone has asked me that send me all your contents of your home directory. So in my home directory, I have directories and files and maybe links and directories, subdirectories, and within subdirectories there are more directories. So how do you put everything in one? Is we use a command tar, and the option that I use is CVF. You could look it up, CVF option, by running man, but I've been using these three option letters for a long time, and I know it will compress it a little and put everything into a file. Then I would have to specify the name of the file that everything will come into. So I'll just put myself, because this is my home directory. I'll just put IMf&x. I'll just put tar at the end. Why? Because this will identify that this is a tar file. And what am I tarring? I'm tarring this entire directory. So I could do home IMf&x. This will tar everything in that, or I could simply do the relative path, which is dot. Dot means tar everything, or put everything that you see right now into a file called ifzol.tar. When I run it, you see all that messages come up on the screen. Some of the messages that you'll see, tar file is archived, now dump. Forget that, don't worry about it, because it's trying to tar itself. That's why you are getting that message. But anyway, when you get all that message, when you run ls-ltr, and you will see right here ifzol tar. Perfect. Yes, so now everything, all the contents, desktop, templates, public, all these files and directories I have are all put into this file. How am I going to untar it? Well, I don't want to untar it in the same directory where all the files already exist. So what I will do, I will create a directory, mkdir, and I'll call it blah, 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 whatever. Okay, the directory is created. Now I'm gonna move this ifzol.tar file into blah directory. Is it moved? Yes, it is moved. So I don't see it. I will go into blah directory now. I'm in blah directory. Just make sure to run pwd. Yes, home ifzol blah. Perfect. Is the file there? Yes, it is there. Now, how do I untar it? Meaning taking out all the contents from this file and putting in this blah directory. There's a command tar, same thing, but this time I will run xvf to extract everything. And this is the name of the file. I'll run it, hit enter. It will come through all these untarring files. And now when I do, remember I am in home ifzol blah, and now when I do ls-ltr, what should I see? Well, I should see the exact same contents I have in my home ifzol. I should see the same contents here. Let's confirm. Bingo. Yes, I do see everything, right? Perfect. So I don't want all those contents in there. I'll go one step back and I'll do ls-ltr again here, and you'll see I have the same thing here. Why do I need to keep two copies? But of course, it's just a matter of explaining you. So let's go back into blah. And this time you'll see I have this file ifzol.tar, which has everything. Now the size of it is 272.58880 bytes. It's huge. I want to compress it. So let's compress it with gzip. Gzip ifzol.tar. Simple as that. Hit enter. You see it took a little longer, but it did compress it. Just look at the size right here. Remember the size, 272.58880. Now let's do ls-ltr. You see the file size went down, 801.8298. It means it has how many digits? 2, 4, 6, 7. This one has 2, 4, 6, and 8. So of course this one was, the size was a lot huger than this one. So it means it is compressed. Then the next command we have is gzip -d or gunzip. What this does is basically uncompress it. So to do uncompress, you do gzip -d, or again gunzip, which is right here, gzip or gunzip. I'll just use gzip, and ifzol.tar.gz. Hit enter. Now the file size should come back to the same one we have right here. This is the original file size, remember? And yes, we did get original file size. So we have tar file, we gzipped it, we compressed it, we uncompressed it. We'll go back to our home directory, and we do have this blah directory, and we'll simply get rid of this blah directory, which is remove -r for removing directory, or rmdir to remove it. Blah directory is not empty, so what we'll do -f to force it. I think my rmdir -f does not work here, so I'll do rm -rf. This definitely work here. Yes, it does. It's gone. Directory is gone. So this is how the tar is explained in simple words. I want you to try the tar file to tar your own home directory, gzipping it, and then unzipping it, or you could even simply take any file that you like and gzip it and see if its file size reduces. And again, the purpose of these commands is if you have to transfer files from one computer to another, or to send it to someone, the file size are huge and the transfer will take a lot longer, and that is why we put them together into tar and compress it, so it'll become a smaller and smaller, and the transfer becomes easier. We're going to compare two files, how that is done. There are two very basic commands that are used in Linux. The first one is the diff, which is going to compare two files line by line, and the second one is cmp, compare, and it does byte by byte. We're going to look at these two commands by logging into our system. We'll use the Putty session, and if you remember the Putty session, we would need the IP address of our machine. If you don't remember the IP address, you could go back into your console, you log in, and you do if config, pipe it more because we don't want to see the information going too fast, so I'm piping it to more, and you'll see the IP addresses right here. You could put that IP address in your Putty and you will be able to connect to it. So let's minimize this and let's see who we are. Who am I? Which directory I'm in? I'm in home. Do what's inside my directory. I want to go into the directory Superman and see what's inside. In Superman, I have I want to remove this file I created earlier, so this way it will be easier for you to understand when I recreate it. So I'll remove it. So okay, so I am in this directory home. I have sold Superman, and I want you to create a file called Superman characters. So let's do echo, and the first character Clark Kent, and put it into Superman characters. Verify it's there. Yes, it's there. And then echo Lois Lane, double Superman characters, echo, and General Zod, Superman characters. Let's do cat, and you'll see it has 3 lines: Clark, Lois Lane, and General Zod. I want you to create another file, call it Superman characters 2. So up arrow key, go back to your first file, and this time I want you to do same thing, and do character 2. Hit enter. Then you'll do the same thing, General Zod, button 2. No, it was Lois Lane. Yes, so Lois Lane character 2, and the last one is General Zod, but this time I don't want you to do General Zod, I want you to do General Peter, and enter. Let's check the Superman 2. Okay, you see the Superman 2 has General Peter and the Superman dash characters has General Zod. Now let's do comparison. If you want to compare two files, we'll do the first one, we'll do diff and Superman characters with Superman characters 2. It's going to tell you the first file right here has the General Zod on it, and the second one has General Peter. Now what if I want to compare it? Superman 2, again you could do just tab and it'll autocomplete, and it'll tell you the last 3 lines, the 330 bytes, that's the byte difference. So that's what the two commands that we use in Linux to compare two files. There is not an easy way to compare two files in Windows. So that's why, again, this gives us a huge advantage to do file tax manipulation in Linux. Again, I want you to do man command on both commands and camp and just learn different options that are available. Hello and welcome to day 3. Today we are going to cover the advanced Linux system administration. So we are almost there, and today is the last day. So I'm sure you guys have spent enough time to go over day 1, day 2. And today is the last day, and I'm sure at the end of today, you'll be able to perform many different Linux administration tasks, even if it's a basic one or advanced one.
Shell. What is a shell? In this lesson, we'll cover about the shell, how the shell works, and how you can run commands within the shell, or how the environment is set up in a shell. So what exactly is a shell? Shell is like a container, like you have like a Tupperware in your home, or any kind of containers that holds your environment, your information inside of it. It's interfaces between users and kernels or operating systems. So you have built an operating system, and then it is provided a platform you to execute commands. Again, Windows is one of the platform in Windows operating system. When you start up a GUI, you execute commands by double clicking on a program. So that GUI interface is your shell. In Linux, when you don't have a GUI, you are given a terminal shell or CLI command. That is your shell. To find your shell, you could run a command like echo $$ and 0 that will tell you what shell you are in. And you could also get a listing of all your shells in your Linux distribution by running the command cat etc shells. Your shell is also inside of etc password that is defined inside of the file. In Windows, GUI is a shell. In Linux, KDE GUI is a shell. In Linux, SH, which is shell, bash, etc. All these are the shell that is provided to a user. Again, we're looking at this diagram again, and we are second from the top. You'll see the application that talks to the shell, and then shell talks to kernel, and kernel is the one that is telling hardware what to do. Let's look at our Linux machine, and we'll see how we could find our shell. We'll open up a terminal real quick. And when you do echo $0, it tells you you are in bash. So you could look at the available shells that is installed in your distribution by doing cat etc shells, and it tells you all the shells that are available. And when you look at the etc password, cat etc password, and you'll see in my username, which is right here, it tells the shell is all the way at the end that I have a defined shell which is bin bash. I could change that shell if I want to a different shell, but I try to keep it consistent with other users. So that's what the shell does, and we'll cover in the later lessons how we could talk to shell to create scripts and other things to automate our tasks. Linux kernel. Do you know there is a kernel in every Linux distribution or Unix distribution? What exactly a kernel is? it actually interfaces between your hardware and your software. So let's look at this diagram. Here you will see you have at the bottom is the hardware. And what are those hardware? Hardware is like CPU, memory, hard disk, and any outside hardware peripheral devices. Then you have kernel. A kernel is a program that is stored inside of your operating system. It's like a program, a command that keeps on running. And what it does is it takes the commands from shell. And shell, what is a shell? Shell is anything like a GUI that we have in Windows or a GUI in Linux. Or if you don't have GUI in Linux, we have terminal that runs bash shell or C shell, which we'll cover later on. So when we are in that bash or C shell terminal environment, we execute commands. The commands are being forwarded to kernel, and it's kernel's responsibility to talk to the hardware that's inside of your computer. And then you, on top of that, you have a browser, send mail, all the applications that we run, like calculator, calendar, Office, or any Linux related applications. And of course, on top of that are the users, and that is you. So shell and kernel together, that software built together in one package, and that is called operating system. And that operating system is any operating system like Linux, Unix, Mac, or Windows. Every operating system has that little program that actually talks to your hardware. And anything that is a shell, which is written in C programming language as well, that shell or those applications are actually the software. So this is what the real kernel means, and we really need a kernel in any operating system to talk to our hardware. Shell history. What a shell history is, every command that you run in your Linux operating system or in your terminal, it creates a history of these commands. This history command, I'm telling you, is so useful that even when you are troubleshooting, you are trying to find out what are the commands people ran that actually brought your system down or crashed your system, or what is the command that was run that deleted a file. All those commands that you run in Linux, just be careful. Those commands are recorded, and those commands are recorded and can be retrieved by simply running a history command. So it's just a history command with everything is lowercase. When you run it, you will get all the listing of your commands that's been run by a specific user. Let's try to run it. I'm gonna log into my Putty session. I am already in here. Who am I? Myself. Just confirm which directory I'm in and which host I'm in. Awesome. We have confirmed that we are logged into the right system. Now I wanted to clear the screen and run history command. Whoa, such a long list of history commands. What it's telling me right here that I have so far, since I have logged into the system, I have ran the history command 666 times. These are the different commands I have ran since I logged in, or since as many times I logged in since the system is built. How do you view other commands? Of course, if you are running Putty, you could just scroll up. But what if you wanted to see all of them one page at a time? Please tell me you know that. History, pipe it, more it. Yes, now it's going to start listing all the commands one by one, one by one. The first command when I logged into the system, the very first time when I built the system, was pwd. Next command I did exit, ifconfig. Those are different commands. As if you could see, you could check every single command that we did. You could also run this command in your shell and find out what are the commands it listed. It's not only going to list the command that you ran successfully, it will also list the command that you ran incorrectly, or wrong command, or a command that did not work. So that's how the history command works. Now, a coolest feature of history command, which you're going to love, that if you wanted to run any of this command again, you could copy and paste, which you could do that, but there's chances that it's not going to get copied or it's not going to get pasted. But if you wanted to run a command again, let's say I wanted to pick a command, I wanted to run last tell you which users are logged in, and awk, it's gonna print out only the first column of the output last, and then it's going to sort it out and it's going to unique it out. Of course, it's a long command. There's two ways you could do it. Is one, you could copy paste, or you could just do 406. Remember 406, that this command, the number of this command was 406. And when you run it, how do you run it? You just simply type bang 406, which is 406. You run it. It ran that command and it gave you the output of that command. Isn't that cool, guys? It is very cool. I use it all the time and I love this, because this way I don't remember a command that I typed maybe 5 months ago. If I go into a history, I'll look into it right away. And if you wanted to do history command and you remember that you ran a command that had awk in it, you were looking for something that has awk in it. So what do? You just grep for awk, and it will list all the commands that I ran that has awk inside of it. If you wanted to do history and grep, and you wanted to check all the commands that has change mod in it, you get all those commands. So again, try it as many times as you want, and please always run man on history, and you will find many information and a lot more options that you could use. Aliases. What are those aliases? Well, in real life, aliases like a short name or easier name or something easier to remember. So I'm sure everybody has like a nickname when you were growing up, and just like other people who are very famous. Just look at 50 Cent. His real name is Curtis James, and there's another one like. Another example would be Pitbull. His real name is Armando Perez. So those are the real names, but their aliases is shorter. So the shorter version and the shorter name they have is because it's easier for people to remember them. So it's the same way aliases work in Linux too. So there are very long commands that you run almost every day, but you need a shorter version of it. And how do you create a shorter version or a shorter word for it? Is by creating aliases. So again, alias is a very popular command that is used to cut down on lengthy and repetitive commands. And some of those examples that I have listed here, we will cover those examples one by one in our Linux machine. So this way you exactly know how aliases work. So let's go to our machine. And we'll go into our Oracle Virtual Machine console terminal, and we will try these aliases command one by one. So the first command I have in aliases is ls. So oftentimes if you want to know all the files with minus L and A option to listing, or A for to also show the hidden files, we will run the command ls minus LA or AL, and you will see all the listing of the files and directories we have in our home directory. And this is our home directory. So time we run that command, oftentimes we'll forget the option. So what we will do, we'll create an alias. So we'll create alias, and instead of just ls, I'll create L equal quote ls minus AL
code close, and just hit enter. Once you hit enter and you don't get an error message back, it means the alias is created. Now, how do you verify if it's created? By simply running an alias. But L was our alias, and let's run it. And there you go, we got the output as if you were running the whole command. Let's create another alias. The other alias, what it will do, it will do the pwd for you and also do ls for you. So two commands in one shot that you don't have to run twice. So we'll do pl. I picked the word just for print working directory, and ls equal code pwd, and you separate each command with semicolon and ls and code close. You hit enter, and now when I'm gonna type pl, I should get pwd and ls command running. So first let's clear the screen, and I'm gonna write pl, and there you go. So the first command it ran was pwd, next command it ran ls. So every time I log into a system, I'll just do pl and it will run those two commands for me. Let's keep going on, and let's try our third one, which has three commands: who am I, host name, and pwd. So I want you to create that alias on your own. I'm gonna go on to the next one. Next one is it will list all the directories inside of my home directory. I could run the command ls-l, and I grab it, and the cap right here that you see, which is on top of number 6, it's telling the grep everything that starts with D. So I'll run that, and you'll see it grepped everything in the output that starts with D. So of course anything that starts with D is what is a directory. So that's what it's getting. So I'm going to create an alias for it, and I'm going to call it dir equal code ls-l, and I'm gonna grab it, the D, enter. Clear the screen, and let's see if it's working by typing dir. And yes, it is working. Then I'm gonna try the last command in my list. So what the last command is doing, sorry, I just have to move this a little more and resize it so you'll see the last command. So what last command is doing is, of course, it's doing df-h. Let's run df-h, which will output your partitions information, the size, where is it mounted, and how much is used. And the next command it's doing, df-h, is printing. It's awking the last column, I believe. Yes, $6. Close. And you'll see it is showing you, let me make this smaller too. Okay, so it's listing everything that is in the last column, which is a column 6. Now I want to get in that output, I want to get only the first 4 characters of this output. So I'm going to run the command again, and I'm going to do cut -c 1 through 4. Hit enter, and there you go. This is what it's telling me, that the last column, these are the partitions that I have in my Linux distribution. Sometimes you do want to run that command just to find out what partitions you have. You don't want to look at other information that df-h gives you. So I'm going to create an alias for that. So I'll just hit up arrow key, of course, to bring the command back. I'll go back all the way to the beginning of the line by hitting the left arrow key. I'll type alias, and I'm gonna name this alias as just D equal, of course I have to put quotation here, double quote, and there is one little thing you have to change here is, you see here $sign. In Linux, $sign has what meaning, if you guys remember? $sign is actually outputs a variable. Whatever that you have variable inside that you attach in the scripting, it actually puts it in there. So it will think that it's a variable too. So we don't want to tell it it's a variable. So how we could change that, or how we could tell Linux not to think it as a alias, as a variable. So I'm going to put backslash. After putting the backslash, I'll move all the way to the end and hit quotation, close, hit enter, and it created my alias. Now if I do D again, let's clear the screen. I'm going to do a D again, and there you go. It's doing exactly the same thing we wanted to do, except with all that long tedious command. You don't have to run it all the time, so it's much easier. Every time you log into the system, you type D and you'll get your information. Isn't that cool? It is very cool, because that's why most of the time people use aliases, so it will be easier to remember and do the tedious work in a very short amount of time. Now, where are those aliases created? Once you type aliases without any creating any new commands, just type aliases, hit enter. You will see right here, it will give you all the aliases that I have created. If you notice right here, this is one, these are the two, another one right here, and then there are another one right here, and the last one. No, this was other ones that are already created. It's already there by the system, by default. It's already there for us, so I don't have to touch it. Now what if I wanted to remove that alias from the list of aliases that I created? Simply, there's a command to do it, is unalias, and you type the alias name. So if you notice, the first alias we have an alias name just D. So I'm going to just type D. It unaliased it. Let's see if it still exists. You just type alias and see if the alias exists there or not. It does not. It's gone. There's another alias, dir. I'm going to unalias as well, dir. And then I'm going to try to check if it's there. Nope, it's gone. So it's just that simple. It's masking something. It's creating a shortcut key for you to run in Linux environment.
Shell scripts and basic shell scripts, and that is fun, and nothing but the fun. That's where we're going to actually write the shell scripts, and we're gonna run very small shell script to get you started, and you will have your own little shell script, own little commands that you could run. Some of the shell script that we could cover is like outputting to the screen using echo command. We could create tasks such as telling what is your ID, your current locations, the files and directories, and some of your system information. Another way, we could create a script that will create your files or directories for you. And then we could also do output to a file within your script. And we could use some of the text processor through scripts. And some of those text processors are like cut, awk, grep, sort, unique, all those different type of commands that we run on a daily basis. We could automate them to see or to get our desired result. So I'm going to get into my Linux machine. I'm going to find out the IP address of my machine, which is 192.168.56.101, and I'm going to log in through a Putty session, which I already have saved. I could also type it in. Once I'm in, I could just simply log in, and I could minimize this, and I could focus on my Putty session. Okay, in Putty session, the first thing we're gonna do is create a directory in our home directory. So are we in our home directory? Let's check. pwd, it tells us we are in our home directory. So I'm going to create a directory within my home directory, and I'm going to call it my scripts. And then I'm going to go into my scripts, but first let's verify if it created. Yes, it did. And then I'm going to go into my script called my scripts. What's inside? Of course, there's nothing inside. I haven't created any file. So now I want to create a first script. The first script is to create is whether you could touch a file and then VI it. But since we have to write a script, we always start with VI. And I wanted to specify the name that would be output screen, just that, or any name that you decide to pick. When you hit enter, it will bring you to the VI mode. You hit I to insert, and if it is a script, you always start with hash bang / bin bash. This is defining that you're gonna run the script under bash shell environment. Now, what do we want it to do is we want it to display something on the screen. So to display something on the screen, you could run a command echo, and then you could type hello world. And once you are done, you could just simply escape and right quit out of this file, and the file is created. You could verify that it has the content that you just added by doing cat output, and it tells you that it does have all those contents that you put it inside of this file. Now, can I run this file by doing dot/output screen? No, I can't, because it's not even telling me that there is anything that exists like that. And it's telling me it's permission denied. Why? Because we do not have executable permissions to our output-screen file. So we have to give it executable permission to all. Execute output screen, and now do ls-n-tr, and you will see it also has changed the color, and it has given executable right to everyone. Now if you run this command, you're gonna see, always run the command. If you are already inside of the directory, you could run the command by / and output. When you run it, it gives you hello world. Hello world. This is your first script, and if you have created this script, I'm telling you, you are already at the initial stage of being a programmer. So pat yourself from in the back, and you should be proud that you could write a script and you could execute it, and it works perfectly. So this is one of the scripts that we did. Oh, by the way, we could also run this script from absolute path, which is home, IMf&x, my scripts, and output. Now in this case, we don't need /. We could just run the script from its absolute path, and it will give us the same output. Now I also have some of the scripts that is saved or written in my WordPad. I'm gonna bring that up, and I'm gonna review them to tell you how we could list the command. So I could just simply copy and paste. So here's another script that will run commands for me. So I'm gonna do vi run commands. It's just a name that I'm picking for a file. Once I do that, I hit I, insert, I go here, copy this, and I'm gonna paste that here. So what it does, the first one, as you should already know, defines which shell you are in. You are in bin bash, and that's where this script is gonna run. The next one tells you the description of the script. This defines small tasks. So I'm gonna run small task. It's just a comment. If I wanted to write another comment, is I could do this script is written by Imran Afzal, or I could also say date that was written in 2018. First thing that this script is doing is doing who am I. Who am I is a command that tells you who you are. Then it's running echo. What echo is doing at this point is only gonna give a break inside of your script, which it's gonna give you a space. When you run this command, you're gonna see the output has a space. Then the next command is gonna run is pwd. Next command is gonna run hostname. Next command is gonna run is ls-ltr. And now at the end, let's run the script. Save it. Sorry, run commands. Oh, what? I cannot run it. Why? Again, I do not have executable permissions. So I'm going to assign executable permission. I'm going to verify it. Yes, now I have it. Run command. There you go. Remember the first one was who am I? It tells me my username, which directory I'm in. This is a directory. And host name. This is my host name. And ls-ltr, the number of files I have inside. And the reason I put an echo in the middle, so I could have these spaces, the empty lines, so it will be easier for me to read it. So that's about getting the task done on our shell scripting, using our shell scripting. Another way, I'm going to cover one more script, is to define variables. When you define variables, it will run those variables to whatever the values I have defined. So I'm gonna create another script called vi variable command. Again, it's just the name of the file that I'm picking. I'm gonna go into insert mode. I'm gonna copy this and I'm gonna paste it inside. Okay, let's look at it. What this script is doing. The first line of the script is basically again defining the shell. Second one is telling me what the script does. Now this one is telling me A is for Imran, B is for Afzal, C is for Linux class. Now it will echo is my first name is $A. So what is $A? Right here, variable Imran. Then echo my surname is $B. What is $B? Right here, this defined variable Afzal. And the third one is my surname is C. Sorry, I should change my surname to my class is $C. And what is that? Linux class. So now let's run this command. Save it. And again, don't forget to change the permissions to executable. And let's run variable command. It says my first name is Imran, my surname is Afzal, and my class is. It didn't tell me the class. Why? Because let's say it says line 6 class this command not found. What's inside of this? Let's look at the file. Why it didn't like it. My class is Linux class. It should say that, but if it is not giving, let's try to get rid of these codes and then run it. My class is still didn't run. Let's try again. See, my class is, because since I have a space, it's not liking it. Let's see why. My class is $C. It should have. Let's try a single quote. And let's see if it works. Yep, there you go. It works. So this double quote doesn't work, single quote does. You might have to troubleshoot a little bit while you are creating your script. So I'm glad I have this problem. So this way you will know exactly when your script doesn't run, how you could troubleshoot. You could tell by the error and you could tell by the line that it would tell you exactly your script did not run because it has an error in line 6. And the line 6 was 1, 2, 3, 4, 5, 6. So that's how the shell scripting works. And I really hope by now you have created 3 scripts, and I really encourage you to go online, find shell basic scripts that you could use and run in your environment and see how it works. Getting internet access to your virtual machine. Now, in this module, we will cover different components of networking. We will learn a little bit about how networking works in a Linux environment. So before we get into the network, we do need to allow access to our Linux machine. And in order to allow access, we have to make certain changes to our VirtualBox manager. Basically, we have to go to the network setting and change its network adapter to bridge adapter. So this way it will get its network through your laptop or through your desktop. So let's go right into the change. All right, this is our VM that is running. I want you to go to the setting, network, and change this attached to bridged adapter. Once you change it, leave everything default. Click OK. Once it's set, let's go to our virtual machine, and then here we will try to do ping.google.com, and right now it's telling me that the service is not available. So let's become root, and then just simply reboot the machine. To reboot is init 0, or just type simply reboot. Let's open up the terminal, and this time I want you to run command ifconfig and pipe it to more, and you will see here the IP address has changed. It is given the IP addresses of the same network that you have set up at your home. So now when you try to ping www.google.com, you should get the response. See, it's getting the 64-bit response back from the server. Ping is the command that is used to communicate to other servers. So now we know that our machine is ready. It's on the network. We could download the packages, we could install the packages, anything that we want. It has ability to go online.
Finding system information. Every time you log into a Linux machine, it is very important for everyone to know which system they are logged in terms of what operating system is running or what hardware it has underneath or what's under the hood. There are a few commands to find that out. Is if you cat out the etc red hat release file, will give you the information about its operating system. The unim -a, which will also give you the information about operating system and some kernel information. And the last one is dmi decode. This command will also give you the information about processor, memory, the hardware that's underneath the operating system. Let's look at each of them one by one. And this time we will log into our Linux machine through console. Okay, let's clear this out. We are who am I? We are root. I want you to exit out of it and become yourself. Who am I? We are ourself. Where are we? Home directory. And once inside of our directory, the same listing of the files. Now let's make this a little bigger. When you do cat etc red hat release, This is the file. It's a text file. It would tell you that we are running CentOS Linux 7.4 and the update 1708. The next command we have that we're going to learn is uname -a. This one tells you this is Linux, the host name of the Linux, this is the kernel version, this is the Red 7 64-bit, tells you the date and time, and when was the system actually was built or packaged together, and again what's the architecture of it. It tells you all the information about the operating system. And the last command is dmi decode. You won't be able to run it if you are a regular user. So see, it says permission denied. So what we do, we become root. Alright, we are root. Let's clear our screen. We want to type dmi decode, hit enter. Alright, so it threw a lot of information on the screen, if you notice, very fast. See, if you scroll up. So we could either do the scroll up, or what's the other way to do? You do dmi decode, hit up arrow key, space, pipe it, and do more. So we could view the output one page at a time. So here, hit enter, and here you will see the BIOS information, the virtual box, what kind of computer it has underneath, what's the ROM size. We created the memory information, the system information, the manufacturer here, manufacturer information, baseboard information. Also up here, we missed one thing. It has a serial number. The product name is VirtualBox. Remember, we are running on Oracle VirtualBox. The manufacturer is Oracle Corporation. Chassis is not specified because there is no chassis underneath. And it's give you some processor and some information about the memory. So these are the three basic commands that I think a system administrator or engineer should know about which system they are logged into, because the first thing, every time whoever logs into the system, they should run the first command is uname -a, which should give them the exact information about the operating system they are logged in. Also, another good command is always run hostname, and this will tell you which hostname you are logged in. So the reason I'm saying the hostname is important is because if you are tasked to reboot a Linux machine and you log into a different Linux machine by accident and you do reboot the machine, then you could cause a lot of trouble. So just be careful, always log in and just type hostname. NIC information. What is a NIC? NIC stands for Network Interface Card. That is something that is attaches to your computer, your desktop, or your laptop. If you look at the back of your laptop, you will see that little port where you connect the Ethernet 5 or 6, Cat 5 or 6 cable to it. That's the card installed in your computer. And the port that is associated or attached to the card, that port is called NIC. In Linux or in computer world, it's called NIC. An example to find the information about the NIC is that you run a command eth_tool followed by the name of your NIC. And how do you find out the name of your NIC? Think about it. How do you find out the information about your NIC? You run the command ifconfig. That will give you all the interfaces of your computer. Now, if you run ifconfig, you will see other NICs as well. What are those? Well, there's one of the NIC that you will see that shows up is LO. LO stands for loopback device. Is a special interface that your computer uses to communicate within itself. It works as a diagnostic and troubleshooting, and to connect servers running on the local machine. So it's like, you could say, a private communication within itself. Then you have another NIC that you probably will see in your machine. If it's a virtual machine, it's VIRBO. This stands for Virtual Bridge 0, interface is used for NAT. NAT stands for Network Address Translation. The virtual environment sometimes use it to connect to outside network. So I don't want you to really focus on VRB0 or even LO, because you will be seeing this, but there is not main function of this. The only function of the interface that is used to communicate to other computers is the third interface, which is usually labeled as, if it's an Oracle Virtual, it's ENP, or if it's a regular server, you're probably going to see ETH0, 1, 2, or so on. So we will run this command ETH tool in our environment and see how we could get the information about our interface. So we'll go into our Linux machine, and this time I want to log into my system using our console. So the console, or you could use Putty session too if you want to. So let's see if I have a Putty session. I'll just execute the Putty session right here. But in order for me to run Putty session, I need the IP address. How do I find the IP address? How do we find it? ifconfig. Now you should be comfortable enough to run this command all the time. Ifconfig, I'll put more, because if it doesn't fit on the screen, it will give me one page at a time. And the IP address that I have for my interface is this: 192.168.1.12. I will log in as myself. And in order for me to run the ETH tool command, I have to be root. So I am root. Let's clear the screen. Let's get rid of this one, minimize it since we already have the Putty. Let's make it a little bigger. And now we'll talk about the interfaces. Again, how do we check our interfaces? Ifconfig. As you can see, we have the main interface right here, which is the one that is used to communicate to other computers or outside world, and it has an IP assigned. The next one is LO, which I have already explained, and the third one is VIRBR0, already explained in my slide. I want to get information of VRBRO, so let's say ETH tool and VIRBR0, and it will say link detected, no, so forget that. Then next one we want to do is ETH tool LO. Link detected, yes, but there's not much information that's out there because it's the system's its own interface, so we don't have to worry about that. The one that we have to be concerned with is ETH tool ENP0S3. Where do I get that? Right from here. See this interface? This is the name of my interface. So I will run ETH tool followed by the name of my interface, and I'll hit enter. Once I hit enter, I have right here my command output starts from right here. This is what is telling me that setting for interface is supported ports is TP, supported link modes, it supports 10, which is 10 meg, 100 meg, and 1000 meg. What is 1000 meg? It's 1 gig. So my interface supports 1 gig of traffic. Nowadays, if you're running your computer on a very high speed network computer, you will see 10 gig right here. So a few things that you do have to get out of this command ETH tool is one, this whether it's link mode is 1000 or 10,000. Second, you have to know, of course, the speed is 1000 megabytes, which is the same as this one. Then you need to know its duplex. Is it full, half duplex? These are the things you have to provide to your network administrator, because when your computer is connected to a switch, and switch has to be configured for your port to allow the traffic to come in and leave your server, your system, your network administrator will ask you for that information. So be ready for that, and remember the command to find that information is ETH tool. And the last one is link detected, that your
Your interface link is up, it's active, it's not down. If you are troubleshooting it, you can find it. If you see no here, then it means there's something wrong with your network card. Alright, try these commands. Run man command on ETH tool and try with different options that is given and see what are the options gives you the exact information that you're looking for. System run level. These are the run levels in the system, in an operating system that brings the system in a different mode. In Windows, you do have a safe mode. That's one of the mode the system brings up, and it doesn't have networking. It just brings you a single user mode. And in other operating system have different modes. Just like that, in Linux, we have 6 different kind of system run levels. The main run levels that are significantly used many times by system administrators is the first one is 0. Every time you type 0, of course preceding with the command init, INIT, followed by space and 0, it will shut down your computer or halt your computer completely. It will not reboot, it will completely power it off. Then you have init 1. It is a single user mode, usually aliased as S, lowercase s or uppercase S. You could type init space S or uppercase S. It will function the same way as if you type 1. Then the most commonly used is 6. When you type init space 6, it will reboot your system. This command is equivalent to command as if typing reboot. The other run levels are run level 2, which will bring the system in multi-user mode without networking. There won't be any network. You cannot communicate to other computers. Then you have level 3, which is a multi-user mode with networking, which is most of the time is the one that is used by us, but it does not have GUI. And the run level 5, which is multi-user mode with networking and with GUI. For our environment, we do have a GUI, so most of the time our run level is 5. But if there is no GUI, you're gonna see that you will be rebooted into the run level 3. So we'll try a couple of these run levels in our Linux machine. Let's log into it. To run any of the system run level commands, you have to be root. You could verify it if you are root, of course, by running who am I. And the first command you have to run is 0, which is init 0 space minus 0. This will completely shut down my computer. It's not going to reboot. I have to go into my Oracle VirtualBox to power it on. Or if it's a physical server, you actually have to be in front of the computer, in front of the rack, wherever it is racked in a shelf. You have to power on to bring it back online. If you type init 1, it will bring down the system and reboot it back in a single user mode. Sometimes you do need to bring your Linux machine to single user mode if you wanted to troubleshoot some issues or reset a password or so on. And then we have init 6, which is just like as if you're typing reboot. Then the other run level is multi-user 2, 3, and 5. Now, how do you find out which run level you are in? The command to find out is who space minus R. R, it's the option that tells you which run level you are in. You will see here it's telling you you are in run level 5. Why? Because they're GUI. If I wanted to bring it into run level init 3 without a GUI, I could do init 3. It will reboot the system, and there you go. See, it brought it back to run level 3. There is no GUI. I wanted to type it in my login credential, And now if I type who minus r, you'll see now the run level has changed to 3 because there is no GUI. If I wanted to just type init6, it will automatically bring the system back online and it will be automatically in run level 5. So that's about system run levels. You could try it on every single option that you see it here. Try it out, practice it, and of course run man on init command.
Trace route. Trace the network traffic. So in this lesson, we are actually going to learn and try to understand how we could troubleshoot the network issues if we are having any network issue in our environment. And one of the commands that is mostly used to see where your traffic is going, which gateway or which DNS server it's going from one to another to the third, and finally how is it going to reach its destination. And to view that entire tracing of those network traffic, you have to use the command trace route. And this is the command, I believe it is also available in other operating systems as well. In Windows, I believe it's called trace RT. I'm not sure exactly what is the command in Mac or other operating system. Anyway, our focus is Linux, so let's see what traceroute does. The traceroute command is used in Linux to map the journey that a packet of information undertakes from its source to its destination. One use of traceroute is to locate when data loss occurs throughout a network, which would signify a node that's down. So as it says, we just need to find the tracing from source to destination, how the packet went through from one to another. Because each hop in the record reflects a new server or router between the originating PC and the intended target. Reviewing the results of traceroute scan also lets you identify slow points that may adversely affect your network traffic. So it could be many different PCs or many different machines or gateways in the middle while your traffic is flowing that could affect your traffic flow. And that's how, once you know, hey, I know this is the machine that is the troubled machine that is causing my network traffic to fail, you could find that out by running the command trace route. Now the command itself is just simple trace route and the destination hostname or the IP address or the URL in this case. So if you are trying to go to a URL, let's say google.com, hotmail.com, facebook.com, or wherever you are going, or if you are in your local environment in your corporate world, you probably have an IP or a host name of your machine. Then you could run traceroute space the host name, as long as your machine or where you are running the traceroute can resolve that host name to IP. If it cannot, then make sure you put in the IP address. Okay, let's get into my Linux machine and then we will try this traceroute command on it and see how it works. So I will go into my console, and first thing I want to make sure I am online, so I could just do ping any website. So you'll see I'm getting a response back, so I am online. So now let's run the command trace route. Now when you run it, you have to specify the host name if you are in your environment, in a corporate environment, and you are running your infrastructure and you probably have a lot of servers, so you have to specify the host name if it could resolve it, otherwise the IP address. But for us, since we are using the lab environment, we'll just do google.com and hit enter. And you will see the first hop it is going to do is it's going to jump on to our modem. This is my modem, which is also a gateway to my traffic. So the first hop it is doing is going to my modem, and this is the time it takes to go there, and it didn't cause any issue. If there was any hang time there, it will tell you this is going to take that much long time to go to the second hop. Second hop is going to another gateway right here, which is most likely my NATed IP, which is the internet IP address or the internet IP, the gateway IP. And then it will tell you it did 1, 2, all the way through the 14 hops to get to this IP address, which is the resolved IP address of the google.com. So this is how you could actually use the traceroute utility to find out how your traffic flows from your source to the destination. The reason it went to my gateway first is because that's how my gateway is defined. And to find out your gateway, you could run the command netstat minus rnv, and you will see the gateway I have for all my traffic should flow from the gateway 192.168.1.1. It might be different in your environment depending which environment you're working on, whether you are doing this lesson through your work, then you will have a different one. If you are doing from home, then most likely you will have the same IP address of your gateway. So this is about the trace route. Try to find it, how you could troubleshoot. Many times people also ask what are the different ways you could troubleshoot networking related issue in the operating system. So you could also bring up this trace route command, and this is one of the uh, main command that will help you troubleshoot networking related issues. If you want to learn more about Linux, check out my best selling course on Linux at udemy.com. Or you could go straight to my website, utclsolutions.com, and you will find the exact same course there.